everyone, welcome back to AthlyticZ. Do you ever watch an ESPN highlight and wonder how do they track that player's every move? In this deep dive tutorial, I'm going to show you exactly how you can recreate ESPN-style player tracking visuals using only Python. We will simulate player movement, convert screen coordinates to court space, draw an NBA half-court using Matplotlib, and animate it frame by frame like a broadcast replay. As always, make sure to subscribe and check out AthlyticZ.com for data science training through the lens of sports. The first thing we're going to do here is simulate some fake tracking data. In the real world, player movement is captured by cameras and sensors. But for us, we'll use Python to generate movement that looks realistic. So we're going to need to import pandas and NumPy. Next, I'm going to create an array of frame numbers for 0 to 249. That's 250 total frames, or about 10 seconds of motion at 25 frames per second. We're going to use the tool Random Normal to simulate small random movements from frame to frame, kind of like a player jogging or shuffling across the court. The tool CumSum adds up those changes over time, so the player moves smoothly across the court. We add 470 to the x-axis and 250 to the y-axis to start the player roughly in the middle of the court. Now we're going to create a list with the player's jersey number, 23, repeated for every frame. That way we can label the frames later on. Next, we're going to assemble all of this data into a data frame. We're going to clip the X and Y values to stay within the screen bounds. That's 940 pixels wide and 500 pixels tall, just like our court image. And lastly, we're going to save the tracking data as a CSV to the desktop so that we can load it or analyze it later. Saving your data as a CSV is optional, but I like to include this step. And lastly, we'll just go ahead and print out the first 5 rows to confirm that everything looks good. So let's go ahead and run this. And there's our first 5 rows of data. The second block of code that we're going to include here is actually just copied and pasted from the previous video where we created a heat map overlaid onto a half-court drawing to visualize the frequency of Steph Curry's shots taken. If you haven't already seen that video, click the link in the description. Or you can just use this code that is also linked in the description. We'll just go ahead and run this so we can be reminded what our custom drawn half-court looks like. And there is our half-court drawing. In our third and final block of code, we're going to animate a player onto the NBA half-court. So this is where we get to bring our data to life and visualize it on our half-court drawing. So let's start out by importing the necessary packages. Before we move on, I'm going to take a moment to briefly introduce you to AthlyticZ data science training. AthlyticZ offers state-of-the-art training for every industry, using engaging examples from the world of sports to keep things fun and practical. AthlyticZ hands-on courses cover Python, R, Shiny, Stan, and more. So whether you're forecasting business trends or analyzing player performance, you'll build real transferable skills. Learn more at AthlyticZ.com. All right, so before we get into the animation, we need to map the pixel coordinates from our sample data into real-world dimensions. So we need to convert pixels to feet to match our NBA half-court drawing. So I'm going to create a new function here called pixel-to-court coordinates, and this is going to convert screen coordinates, or pixels, into court coordinates, or feet. So essentially, all we're doing is scaling the X coordinates from 0 to 940 pixels, to negative 250 to positive 250 feet. And we're scaling the Y coordinates from 0 to 500 pixels to negative 47.5 to positive 470 feet. This is the real half-court size in the NBA. All right, now we are ready to create a loop that goes from frame 0 to frame 249. And each time we go through this loop, we'll draw one frame. I'm going to use the clear output tool to clear the previous plot from the screen. So this just gives the illusion of motion. Next, I'm going to create a fresh figure and axis for each frame. We're going to be drawing our court and player onto this canvas. Then we will call the function that we used to draw the NBA half-court. Remember, this is just the function that we copied and pasted from the previous video. We're also going to grab the row of data for each frame in our data set, one at a time. Now we're going to loop through each player in this frame. Right now we only have one player, but you could easily scale this up if you wanted to incorporate multiple players or even have a whole team. We're going to convert the player's XY pixel location into feet so that it lines up with the court correctly. And we're just using the function that we defined earlier, pixel to court coordinates. Next, we're going to use these coordinates to plot a red circle that will represent the player, sort of like a tracking dot that you'd see on ESPN or Second Spectrum. We're also going to add the player's jersey number just above the dot. This is not super important while we only have one player, but if you scale this up to show multiple players, you'll want to see jersey numbers. I also included the round function to make sure that the jersey number shows up as a whole number and not a decimal like 23.0. And lastly, we're just gonna add a title. I went ahead and hid the axes for a cleaner look. And the last line of code here is to display our animation. And the very last step is to use the time sleep tool to tell Python to wait 30 milliseconds before showing the next frame. That equates to around 33 frames per second, which will make our animation look like a smooth video. All right, let's go ahead and run this last block of code. And now we start to see our animation come to life. Mine is running really slowly right now because I'm screen recording, but ideally you would be able to see 33 frames per second. So we have our half-court drawing with our red dot and the player's jersey number. And it's basically just going through each frame one at a time, so it kind of looks like a video. I hope you enjoyed this video, and if you found today's tutorial helpful, please give it a like, and make sure to subscribe for more Python tutorials. Thanks for watching.